We'll now start looking at some more complicated probabilities, and we'll start with our multiplication rules for probability. The first thing we need to know in a multiplication rule is, are our events independent? Independent events means the occurrence of one event doesn't change the probability of another. As an example, if I were to flip 2 coins, what happens on the first coin flip does not affect what's going to happen on the next coin flip. Same thing with rolling 2 die. Rolling 1 die and getting a number does not change or affect what's going to happen when I roll the second die. And for these independent events, we're going to look at the probability of A and B both happenings. We want the chance that both things are going to happen. This is the probability of A times the probability of B. But this only works if our events are independent. What if they're not? If our events are dependent, then the probability of something happening is going to affect the next thing. For instance, if I'm drawing cards, once I draw the first card, if I don't stick it back in the deck, it's going to change my probability of the next card I'm going to draw because I can't redraw the first card. That would be an example of a dependent event. And the probability of these gets a little more complicated. For dependent events, we have to introduce this idea of conditional probability, which is this thing here. You'll notice the bar, which is read given. This is the probability of A given B. And it means exactly that. What's the chance of A happening, assuming that B already happened? And so if our events are independent or dependent, then the probability of A and B both happening is the probability of A times the probability of B given that A already happened. And the big distinction here is that our probability of B is changing based on whether or not the first thing occurred. So we're going to assume that it did. Let's do some examples to show how this is used. Let's suppose I roll 2 dice, and I want to know what's the probability of rolling 2 3s. So I want a 3 on the first and a 3 on the second. Well, for our first dice, there's 1 3 and 6 sides. And our second dice, there's 1 3 and 6 sides. And these are going to be independent events. Because, well, rolling 1 dice does not change what's going to happen on the other dice. So we have 1 out of 36. Let's look at another example. Let's suppose we have a bag of marbles that contains 3 red, 2 green, and 1 yellow. And I want to know the probability of drawing these at random, where I first draw a red one and then draw a green one. So my probability of red is going to be 3 out of a total of 6. The probability of green, well, there's 2 greens in here, but we assume that we drew a red already. So we're already missing one of our marbles because we've removed 1 red marble. So now we're at 2 out of 5. So now this would be 6 over 30, or 1/5.